It's wonderful to be here. Thanks, Mania and Christine, for inviting me to such a wonderful venue. It's great, isn't it? I should have been a GP, is what I reflect on. So I'm going to canter through this so we get to coffee. So I'm going to try and convince you that big data or data science is non-negotiable. And it's not only if we're going to deliver on stratified medicine and Genomics England, but it's also about sustainability of health systems. We've not brought data science into healthcare. So that's the script for the next 20 minutes or so. So I'm going to suggest that we need to do this at the UK scale. And if you look at my first slide, I've put the logos of every health department in the UK, because our ambition should be to do this for 65 million people, to provide equitable care wherever you live in the UK. So I'm going to suggest we can gear the UK for stratified medicine and research, that data science is the catalyst for change. Now, definitions are important. So my definition of data science is the interface between statistics, mathematics, computer science, and domain. And our domain is healthcare and life sciences. So let's see how interdisciplinary you are. How many statisticians in the room? Oh, blimey. You're not outliers. That's good. Mathematicians? Oh, a few less. Nice to see you. Computer scientists? Okay, so that's pretty interdisciplinary. And life and healthcare sciences? Yeah. So I predict in 3 years' time, it'll be 30, 30, 30. Okay? And any GPs? Nice to see you. So I'm going to suggest to you the challenge is the phenotype of the genotype. Why did GEL have to dig data out of 600 systems in one hospital? That's not efficient. So we really need to look at how we characterize phenotype. And then lastly, talk about the governance piece. With big data goes big responsibilities. But this isn't just healthcare. If you went to Davos this year, they're talking about the fourth industrial revolution. You'll be familiar with the first one, which was the help of water and steam power about 200 years ago. Tim remembers this. The introduction of electricity, which facilitated automation. The third one was digitization, how we share information. The argument is that we're not seeing a progression of digitization, but this is a new era about how we learn and use data in real time. Why? Because of the speed of change. It's exponential rather than linear. Secondly, it's impacting virtually every industry in every country. But thirdly, it's very disruptive. Very disruptive in terms of how we productize, how we create new markets, but also the ethics and governance. So the challenge for me is, can the UK be a leader in the fourth industrial revolution? And just to show you where we're going, in the 40s, we had one computer, many users. We're now looking at intelligent environments where everything has a computer embedded within it, the Internet of Things, or indeed the Internet of Nano Things, in terms of this fusion of biology, of digitization, and the physical sciences. So, just to show this is true, I graduated as a doctor in 1987, and this was state-of-the-art computer science in 1987. Do you remember that? It was the year the floppy was launched, and actually this was an expensive big one, because it was 1.4 megas. Does anyone not remember that? Oh, yes, you're very young. Right, okay. So where are we now? We've gone to gigas, teras, exas, petas. We're up to zettabytes. So the World Wide Web holds 5 zettabytes of data. So that is what we're seeing just in storage. So this is my mate, John Mattison, who's the CIO of Kaiser. And it's one of his slides, and he illustrates that healthcare is becoming increasingly data-intensive. We're not going back. In terms of internet and cloud, smartphone, socialome, the quantified self. How many Fitbit users? Any here? Yeah, about 40% of you. The exposome, environmental sensing, geospatial data, and as we've heard, isn't it exciting? We can do the $1,000 genome. So this is here. The challenge is how we turn these data into knowledge at scale. And what we're seeing in computer science is not only an advance in storage or an advance in sensors or robotics or natural language processing, we're seeing applications which see a confluence of these methodologies to deliver value and deliver new products. So examples of that, so this is some work we've been doing up north on cognitive computing and natural language processing. Most of our text, most of our data in the health service is in text. It's not digitized. So we asked the question, can we codify a medical record from outpatient letters, from pathology reports? And yes, you can. So there's an example. Here's another example. This was in Nature a few weeks ago. This is from Sebastian Thrun. He was actually the head of R&D for Google, now working for Verily in life sciences. He took 130,000 pictures of skin images and used deep convolutional neural networks. It's like a decision tree approach. And he was able to differentiate malignant melanomas versus benign skin nevi, and he outperformed 21 certified grade dermatologists. Okay? He was able to subcategorize 2,000 diseases using machine learning of images, and his ambition, he's saying, well, there'll be 6.4 billion mobile phones on the planet by 2020. Why don't we put it on an app on a phone? So that was in Nature a few weeks ago. So this is possible. It's also fraught with problems if you don't get the chemistry right. So this is just last week. The president of MD Anderson, one of the world's greatest cancer centers, resigned because they've struggled to get integration of IBM Watson into a cancer center at scale. It's really challenging, and it cost a lot of money. So this is going to be hard work, and there are already some scars out there. Okay, so our thesis in the UK is to accelerate translation from excellence in life sciences, as you heard from Tim and Sue, to world-class patient care using data science, maths, statistics, computer science, medicine. And we have to be cost aware. We can't just keep adding costs to our systems. So better quality, reduced costs. That's why the health economics stuff you did, Minnie, is so important. We've always got to be cost conscious. So I'm just going to give you one or two examples. I was asked to use sort of the northern state of Scotland as a case study. So here it is, our new official map of Scotland. Hope you like it. So I sit on the board which administers health for 5 million people, £12.5 billion a year we spend on this. But what we've tried to do is create a data-intensive environment for the whole of Scotland, and we're not there yet. Tim's vision for doing this across the UK, I think, is absolutely right. To do this once for 65 million, it'd be tricky to get our arms around. So let's standardize across excellent health economies. And for years, we're great at measuring process. So how many times patients show up at their GP or show up at hospital 1.5 million times a year. The prize, and it's a big prize, is to move from real-time measurement of processes to outcomes meaningful for patients. And that's phenotyping, consistent phenotyping at scale across journeys of care. We've been able to do it because we've had the NHS number for about 30 years. We stole it from the Danes. And I think we've now got an NHS number across the UK, and we should use it because it allows one to do this. You can link journeys of care. And with chronic disease, multimorbidity, these journeys of care are becoming really complex across general practice, pharmacy, diagnostics, laboratories, hospital data. But that's what we've done, and that's what GEL has done for rare diseases. It's created a phenotype across journeys of care. So 3 examples of that very quickly. An emergency care summary. So this is for 5 million people. So wherever you're admitted to in Scotland, 38 hospitals, you can see my health record from the GP, and it's accessed 3.5 million times per year. And it changes management, 20%. Very, very crude. Again, a consistent approach to PACS, which is radiology. There are about 3 million tests per year. There'll be 30 million in the UK a year. But what we've done is established a platform as a service for all our imaging, which is 21 million studies for care. And now we've got agreement to put it on the supercomputer for research. Unstructured data, great for phenotyping. And my own world, and Ewan, if he's here, his plane was late, I think. We'll talk about this, but for the last 15 years, we've had a single clinical information system for every person living with diabetes in Scotland, updated on a daily basis between 1,000 practices, 38 hospitals, and it's given us, by linking to DNA and longitudinal phenotype, opportunities for population pharmacogenetics. And it looks a bit like this. So it's very similar to the platform sitting on the NHS that Tim alluded to, but for diabetes. So Helen Cahoon and colleagues have looked at classical epidemiology. She's also looked at biomarkers by looking at, through the Summit, the IMI program, looking at biomarkers predicting cardiovascular disease. And Ewan, who you'll see later, he doesn't look quite as young as this now, actually, has led the charge on pharmacogenetics. So collect data once and use it often. Okay? So this is our current platform sitting on the NHS. It's about 42 national data sets that we're running 300 studies off with good governance, ethics, single approval. So it's imaging, it's lab, it's A&E, dental, sort of cradle to grave. It's not one database, because the public don't want that, but it's the ability to link, to ask legitimate questions. So that's what we've done through the FAR investment in Scotland. So what can we do with this? Collect data once, use it often. There's a whole host of issues. If we just promote this for the research and the genomic world, I think we'll lose traction with the public and the NHS. It's about saying there's a whole host of uses listed here. So very quick examples. Evidence-based policy. So Jill Pell in Glasgow has really led the charge here. Some very simple studies, but important studies. For example, the Back to Sleep campaign. Do you remember that? Put your baby on his back. Did it work? So Jill showed that it had a major effect, especially if you are affluent. Within 6 months of the campaign, the rates of infant deaths fell very quickly. But look at the time it took for the most deprived people to reach the same rates. So very simple. The smoking ban, did it work? Hospital admissions for 5-year-olds for asthma in Scotland. This is in the New England Journal. Before the ban, a 5% increase. After the ban, 18% decrease. So answering very important public health questions. Earlier diagnosis. As we stratify, don't forget the phenotype. So here's an example of stratification based on phenotype. In diabetes, we photograph everyone's eyes annually. Is that right? Can we safely offer people shorter or longer screening intervals? So what Helen did was use our own data. It's quite a busy slide, but looking at folk with type 2 diabetes and 2 examinations showing no visible retinopathy, you can quite safely offer those folk screening every 2 years instead of a year. So we're spinning knowledge back into the health system, a so-called learning health system. And that's important because we screen 44% fewer people. Now, as a doc, I would say, oh, we need more cameras, we need more graders because we've got all these new patients. It's about stratification of clinical pathways based on clinical need, and we need to do more of that based on phenotype and genotype. Safer and more effective treatments. So we've got a nationwide prescribing database, person-specific, 610, we use a lot of drugs, 610 million items, and one can link that to other data systems. So an example from Aziz Sheikh is looking at drug safety on a national basis. And I would like the UK to be the world leader in pharmacovigilance, safety and effectiveness of new therapies in terms of near real-time health technology assessment. This example is of varenicline, the most effective smoking cessation therapy, to show that the case reports of neuropsychiatric side effects were probably over-egged. More effective integrated pathways. So gel's a great example of this. So here's an example for cancer. Currently, we've got investment to follow the journey of care of all 300,000 people living with cancer in Scotland. linking both the phenotypic to the radiological and the diagnostic data. Because as a clinician, I would like to support my oncologists to be able to click on their own caseload and see where their patients are across the journey. Only if we get this phenotype sorted will we deliver stratified medicine. And this is an example of the use of cetuximab on a nationwide basis across all the cancer centers. So local, regional, national, using the same data standards. Driving clinical research. So I'm very interested in this. The NIHR thrust on joint dementia research. Our experiment led by Colin and Brian is so-called SHARE. So this is trying to embed research within the NHS. So people do two things. They consent for their electronic health records to be screened for future studies, and they consent for spare blood to be collected. So we are very happy. The 100,000th volunteer was this very famous scientist. Here she is. But we're getting public support to embed research within the NHS. So this is the age range of SHARE. We've now got 156,000 people. We want 1 million across the UK. I would like 10 million. And we can link to prescribing. So this gives you a platform for population-based pharmacogenetics. Why? As you can see, we use a lot of drugs in the first 100,000 people. Almost 60% of people were on a GI drug or had been exposed to one. We use a lot of drugs. So what is new is about getting spare blood. As a community, if this room, 75% of us will have a full blood count done in the next 3 years as an EDTA sample, which you can use for genomics. So what we do is cherry pick that from the NHS and store it for research. Very efficient way of running studies. And Ewan will talk about how we're now running recruit by genotype clinical trials for pharmacogenetics. And we've put it on an app. So please, Google SHARE and sign up today. So if you ever visit Scotland and are hospitalized, we'll collect your blood. What about this precision medicine discovery science? It's the same model. It's the same precision. Let's think UK. Let's think UK. It's the same model. And it's important to think the UK. Why is it? So this is the Mike Stratton paper on cancer. He looked at, I think he looked at 23 most common cancers, and he looked at common gene expression, hoping there'd be 2 or 3 genes, which explained a lot of cancers. Sadly, it wasn't the case. Every cancer is a rare disease. Only in 13 genes was there a more than 5% commonality of mutation. So every cancer is a rare disease. And that's important as we look at pharmacogenetics. Why? This is a thought experiment. How many millions of people does it take to get 250 a year, new cases, so-called incident cases of new disease, of a specific cancer and a biomarker of various frequency, okay? So let's look at common cancer, lung. So if we're at 1% frequency of mutation, you need 47 million people to get 250 new cases. A rare cancer, liver cancer, at 5% frequency, you need 90 million people. If you do the maths, we can only do those cancers below the line in the UK. That's the best UK registries, and that's the whole of Europe. We've got to think of scale. So it is about getting alignment of phenotype across GP, hospital physicians, with molecular pathology, with treatment choice, with clinical outcome. That's the prize for the UK. And I'm delighted, because this is our flagship, Genomics England, but it's now working across the UK, isn't it? So working in Scotland, Northern Ireland, and Wales at scale. Okay. And I've got to flag biobanks. This just shows you I was up late last night. This is news today because the excitement is that GSK and Regeneron are to mine the gene data from UK Biobank and have funded, I think it's whole exome, isn't it, across UK Biobank in the news today. What a great resource. The UK are really at the cutting edge of this activity. So very briefly, in the last 5 minutes, how have we been trying to weave this together? Because it's a bold, ambitious endeavor. It's full of risk, full of competition. But one or two examples of what we've done. First of all, credit to 10 funders across the UK. They came together and said, well, we'll have an experiment on electronic patient records in Scotland, Wales, this is Harry down the road, and Manchester, to create the FAR Institute, to lay a foundation for this on the EPR side of things. I know we look like 4 UKIP candidates, but we're not. But we have to credit the funders for coming together. And basically, it was doing the things which Sue said, research, harmonized infrastructure, public engagement, governance, capacity building, and partnerships. So this has been going about 3 years, 3.5 years. So where we are, we've published. I'll skip through these because of time. Secondly, we've built research infrastructure. So this is the Scottish collaborative environment where NHS, academia, and industry can come together. Even government put analysts in this building, asking questions of the same data resources. The government love it because they're quite parsimonious and they love the free parking, you see. So always a good trick. Just down the road, in Euston Road, there's FAR London. You do need infrastructure where people can breathe the same air. And this is Manchester. The compute, so we've got compute. eMed Lab's a good example. The Genomics England data centre. So in Scotland, we've put the nationwide data sets on the national supercomputer. It's called Archer. It's a £100 million investment. Instead of us all having our data under the desks, those days are gone. And it's run professionally. It's GCHQ accredited, as the question suggested. It's running 300 projects, and it can look at prescribing, imaging, laboratory, and genomics data sets in this reading library analogy. So we need to integrate our capability across the UK. We're showing we can do that through dementia. The Dementia Research Platform is a similar approach. In Manchester, Ian Buchan and colleagues have got the Connected Health Cities. So there is convergence coming over the horizon. And in East London, all credit to Luke Redman and colleagues, for a population of 1.3 million, 700 GPs, they've got a similar mode. So we're seeing these data-intensive economies emerge. Third issue is capacity building and support the next generation, because we're all getting too old in this space. So I think we really need to support the next generation. Governance, how do we get proportionate governance in this space? So Graham Laurie has been a real leader of this for UK Biobank and many others. So we have proportional governance approaches which are now embedded within policy. Public engagement is key, which we talked about. We'll maybe touch on that later. And industry engagement, which the slide seems to have disappeared. So in the last, have I got 2 minutes? Is that okay? Looking ahead, because none of this stands still. The exam question is, can we build a UK-wide ecosystem? I'm doing work in Shenzhen in China. It's the sort of Silicon Valley of China. 2 million people with diabetes in Shenzhen. 100 million people with diabetes in China. So if we're going to compete, we've got to think of detail and scale. Detail and scale. So the first challenge is reducing the complexity, because there's a real risk we have competing programs. This requires deep collaboration at scale. And to do that, we need to look at our standardization and interoperability. So industry says, what is interoperability? To work across systems with no additional effort. Sometimes it seems that interoperability is to fail to work across systems with a huge amount of effort. So we've got to flip that equation. Secondly, I've talked about the tidal wave of data. Thirdly, the direct-to-patient thing I think is fascinating. We're doing it with Share, but look at, as ever, Apple are ahead of us. Research Kit. So Google Research Kit. Stanford University recruited 11,000 volunteers for a cardiovascular trial in 1 day. That's pretty good, isn't it? 1 day. So, and this will become more and more prevalent. Fourthly is the digital maturity of our health system. Munir, well done. Today's all about personalized medicine and prescriptive analytics. But if Sue's going to realize her dream to get it in the NHS, there needs to be sufficient digital maturity. So this is a pretty crude scale, but it's useful. You know, how mature are our hospitals? So we did some work across UCLP, and we're sitting about 2.3 on an 8-point scale. We've got 600 systems for a hospital. So we've got to think how we address that. And I must credit the work that's going on under Wachter. He was Scottish, you see, Wachter. There is a national engagement strategy, but importantly, build CCIOs in the NHS who know about informatics and data science. So I think this is very important, and the Digital Academy will achieve that. Fourthly, and this is to promote Ewan again, he still looks young there, it's the ontologies. We got to agree to agree. So Ewan emailed me, he says, Andrew, these are the top 20 ways we prescribe metformin in Scotland. Okay, I said, that's very interesting. And he said, Andrew, these are the bottom 20 ways we prescribe, because it's a mixture of Roman, normal numerals, text, spelling mistakes. Take 1 Twix a daily. But this is medicine. So in total, there are 5,700 ways. 5,000. Now, we can try to sort that with computer science, but surely let's correct it at source. How can we have precision medicine without precision prescribing? I talked about the interdisciplinary. This is my mate. I share an office. So he's the head of the School of Informatics. More computer scientists. So next year, more computer scientists. And lastly, the public interest mandate. How do we explain why the benefits, the safeguards, and how we're mitigating risks? This is not a big UK database. It's about using data in a smart way to inform and improve people's lives. Because at present, Maury tells us the trust in data deficit, and we can't do enough public engagement. And as I suggested, I think there are models across the UK of best practice. Let's share them. Let's share them. So looking ahead, today it was announced that we're going to have a Health Data Research UK, HDR UK, which will be the National Institute for Health and Biomedical Informatics Research. Graham will be the chair. I've been very fortunate to be appointed the inaugural director, which suggests there'll be more than one. But my view is how can we collect data once and use it often across these domains? Yes, public health, learning health systems, citizen-driven health, but yes, molecule-to-man precision medicine and discovery science. That's the prize. So very briefly, it's not going to be a club. It's going to be open. We've got 40 research organizations expressing interest, working with the NHS. It's the ultimate challenge in team science. How do you allow people to flourish and receive recognition whilst working within an ecosystem? And initially, we've got £50 million. So my mobile phone's been very busy this morning. So we're looking at leadership across the UK, skills and capacity, these research environments, the computer science bit, partnering with the NHS and building public trust. So this is happening. I'll move into post on the 1st of August. And the model is we'll set up a single legal entity, a bit like GEL, UK Biobank, and it'll be distributed. We're not going to build a cathedral. Let's look at what we've got and work with people who have the skills and the talent to deliver. So to summarize, I think there's a huge opportunity for health data science across the UK. I do subscribe to the view of local, regional, national. So these regional advanced clinical research information platforms feeding into a national infrastructure will be, to my mind, a sensible approach. So what do we need to do? The C's, commitment to public engagement, convergence of care with innovation and research so that we work with industry in creative ways. The ontology piece is important. Collaboration is absolutely vital. Commercial engagement, but with transparent governance and benefit sharing articulated. The computer science bit and the clarity about the governance and the data share. And I would like to see the UK lead in the 4th industrial revolution. Because if we compete and we squabble, China will win the day. Thank you very much.